the projection of straight lines, but I thought we'll start with the projection of planes today, and I will come back to the projection of straight lines then once we start the classes. Okay. So today we start with the projection of plane surfaces. Yeah. See, as we know, the projection of plane surfaces is one choice question. You're going to get it along with the projection of straight lines. And understanding the projection of planes is very important for you because it will lay the foundation for you for the projection of solids. Okay. So what we do here is first 1 hour. I will explain the concepts of projection of planes, how we can draw the front and top views of planes, different planes. So which has been positioned with different uh, positions in with reference to the reference planes VP and HP. And later part in the next second hour, I will just explain you, and I will just go to draw how to solve a problem in projection of. So this has to be done simultaneously in the sense you people supposed to have sketchbooks if you are having now. Otherwise, please take a sheet of paper, plain sheet of paper, and have a drawing instruments with you. Okay. The first 1 hour, I will complete all the concepts, and in the second hour, we will start solving the problem. I will just do it on a board, and I will go to explain you how the projection of planes can be done. So once I do that, so simultaneously I will keep on explaining, and you will be simultaneously you will keep on doing it on your sketch or your plain sheet of paper. So this is what I just planned today. So once we just keep on sliding the PPTs here, I think you cannot do that, you cannot understand that because unless you practice it, it's very difficult for you to understand it. So therefore, so we will plan in that way. First 1 hour, I will be just keep on explaining the projection of place concepts, and in the second hour, so we'll start solving the problem. So which happen, it has to be happen simultaneously. Means I will be doing it on a board, okay, and you will also be doing it on a sketchbook or a plain sheet of paper simultaneously. This has to be done. Okay. Yeah. Let us start with the projection of planes. Yeah, of course, so we will go to start with the first angle projection, only as I already been discussed in the class. Once we start with the projection of straight lines, the method of projection will be only the first angle projection. In the sense, the object will be kept in the first quadrant, and we will be observing the object from the infinite distance, and its corresponding views will be obtained on a vertical plane or on a horizontal plane. So correspondingly, what we call it as a front view or a top view. So here, the object is a plane. So I think we discussed the projection of straight lines. The same concept here. Only thing is the object is changed. Instead of a straight line, so here we have a plane. So when a plane is being placed in a first quadrant, is the different positions. So and observing that plane from an infinite distance, and the image what you are going to obtain on a corresponding plane, which is being kept perpendicular to the direction of your visual rays. So that we call it as the projection of planes. Okay. So simple example, if you keep a triangle or a rectangle or a square or whatever it might be in the first quadrant, and it is in the quadrant, and you observe in the front view or in the front from infinite distance. So the image what it is going to form on a plane, that is a vertical plane, is the one which is being kept perpendicular to the direction of your views. And that corresponding view, we call it as a front view. And the correspondingly, the same object has been viewed from the top. And the view or the image, what we are going to obtain on the plane which is being kept perpendicular, that is a horizontal plane, we call it as a top. So this is what we were learned in the class. Of course, same concept will going to be continued over here also as what we discussed in the straight lines. The planes also, only the change what you can notice here is the object change. The change is object. So there it was a straight line. Here it is a plane. Okay. The only thing is the complexity. Complexity in the sense number of points, number of annotations will going to increase here, and we will be keep on getting the concepts from the two-dimensional to three-dimensional X to the solids. Like that will be the object will be keep on changing. Okay. In today's class, we'll start with the projection of planes. As we know, a plane is a two-dimensional geometrical entity. It has a length and width, but no thickness. For practical purposes, a flat face of an object may be treated as a plane. A plane or a lamina. So it has got another one name called a lamina. Anything you can call either a plane surface or a lamina or a plate, whatever it might be. Everything constitutes to the same thing here. This plane will have two dimension. It is a two-dimensional object or two-dimensional entity, and it has been represented only with the length and the width. And the thickness will be there, but thickness will be very minimum, and hence we take it just will take it as a negligible thickness. And the plane will have a two dimension. So therefore, it does not have. Generally, we say that plane does not have a thickness. And for all the practical purposes, any flat face you take, flat face of an object, that will be treated as a plane. Okay. So generally, in when you are just describing a plane, the information usually given to you is shape of the plane, inclination of its surface with one of the reference planes, inclination of its one of its edges with the other reference planes will be given. In the sense, what I am talking over here is when a plane is being positioned, so you can position the plane in an infinite ways, infinite directions. So when you want to obtain an image, when you want to obtain a view in a particular position, so you need to know what is the inclination of the plane with respect to the reference plane. First of all. And sometimes how the edge at the corner or other will be given is being inclined to the with respect to the planes that will be given. So I will just discuss these things in detail later part. So only just I have just given here is information usually given shape of the plane. So either the shape might be a triangular lamina, or it might be a square, or a rectangle, or a pentagon, or a hexagon, or a circle. So anything. So these are the six type of planes what we'll go to discuss in our engineering graphics. So any one of these shape will be given for you, and then their inclination with respect to the reference planes, how it is being inclined, and inclination of one of its edges, surface inclination and edge inclination. So those two things will be given for you, and taking those data, so we need to project the planes with the different orientations in the form of a front view as well as the top. Okay. Yeah. Next is the types of plane figures. So we have just what I was just talking about the different planes over there: square, rectangle, triangle, pentagon, hexagon, and a circle. So any plane figure, so it has been formed by simply we call it as a polygon. A polygon might be a polygon and one with sides. So if a polygon is having three sides, the number of sides is three. We call that as a triangle, right? So triangle will have edge. So edge we have shown over here. So this is the edge of a triangle, and the two edges will meet at a common point, what we call it as a corner. So why I'm talking this is, see, when we are drawing the projection in our engineering drawing, generally the projection will be given with respect to the position of the lamina will or plane will be given with respect to the edge or a corner. So this is very important for us. Why? Because this will play a vital role. So here, the initial position, what we call it as, so initial position resting the lamina either on the edge or on the corner. This is one of the most important steps in engineering drawing. Means either you have to rest it on the edge, either you have to rest it on the corner. So this is why I'm just talking about these two things here, edge and a corner. These are the two important things. And these two important things, so yeah, these two important things, edges and corner. So it will play a vital role for us. So therefore, what we do here is, so just I'm just shown the edge and the corner for each and every plane surfaces over here. So triangle, this will form an edge and this will form a corner. And of course, a square, this is an edge and this is a corner. Corner means where the two edges will meet. So that is what we call it as a corner. And of course, these are very simple things you can understand easily. Of course, pentagon. So square basically it is a polygon having your four sides. So I think all these things I have discussed in the first class itself when we have done the geometrical constructions. Okay. So properties of a square and how to construct the different planes. So triangle we did, square we did, pentagons, hexagon. So please, all those things are very much required now. So you should know how to construct this regular pentagon or regular hexagon or regular polygon. So square, we already know what is the properties and you know how to construct a square. And this is a pentagon, pentagon, a edge, corner, and again here is a hexagon, edge and corner. And finally we have a circle. So circle does not have any edges over here. So it will have a different way of dealing this circle. So that we will go to take it at the last part of this chapter. Okay. So this is just an introduction to the different planes and two important terms. One is called an edge, another one is a corner. So because you should be in a position to distinguish which is an edge and which is a corner for all the types of planes. So this is, I will tell you the importance of this later part when we start solving the problem. Okay. I hope you are understanding. Okay, I will give you time for you to have any clarifications after completing 2 minutes, and you can just talk to me later. Okay. Let us take the next slide where we have orientation of planes in space. Means you can position a plane with respect to the reference planes in a different ways. That's what I was talking about. You can position in an infinite ways. And all those infinite ways can be just put together. So we have listed out a certain positions of the planes, the standard positions, what we call it as. So the standard position, just I will just read it out. Just look at that, and afterwards I will just explain each one how we can do that. Right? Planes parallel to VP and perpendicular to HP. Second one, planes perpendicular to VP and parallel to HP. Planes parallel to both VP and HP or both perpendicular to VP and HP. Planes perpendicular to VP and inclined to HP. Planes inclined to VP and perpendicular to HP. Then the next one is planes inclined to both HP and VP. This is similar to that what we discussed for a projection of straight lines. I think in the class I discussed the different ways we can position a straight line. It is similar to this. Same thing, no changes over here. So there was also same positions I have discussed, and only this what you need supposed to change over here is instead of a line, here we have a plane. Okay. So this is the different positions what we will going to have the planes. Okay. So this is what we call it as the first one, position in projection of planes. A plane perpendicular to HP and parallel to VP. A plane perpendicular to HP and parallel to VP. Look at this here. Plane perpendicular to HP. So you will go to position the lamina in this way. So we have taken a square lamina over here. So here we have a plane which is been perpendicular to HP and it is parallel to VP. So this is a vertical plane and this is a horizontal plane. Okay. So plane perpendicular to HP and it is parallel to VP. So in such cases, so the true shape of a lamina or a plane can be seen in the front. So this is what I was just talking in the class when we were just discussing the projection of straight lines. An object which is parallel to the plane, you will going to get a true shape and a true size. The same concept here also. So here, the true shape is obtained on a vertical plane because the plane is parallel to B. Okay, so the true shape you are obtaining it on a vertical plane, and once you observe the same plane in the same position from the top, so you will going to see only the line. So the line which is visible from the top is only line AB. See, look at it here, this square A, B, C, D. I think you can see this A, B, C, D over here, right? And observing from the front view, from front, so you can see complete square in its true shape and its true size, and that will be projected on a vertical plane. So A dash, B dash, C dash, and D dash. This is what we call it as a front view. So I think in the first class in the projection of straight lines, I told you how to represent a front view and top. So front view will always be accompanied with a single prime, whereas a top view will have only the alphabet without any prime, whereas a side view will have a alphabet with a double prime. So please remember this. Okay, front view with a single prime, top view without any prime. Right. So same square which is being observed from the top view, you can see only the line AB because it does not have a thickness. It is a plane. So line AB, and you can see the same thing is being projected over the horizontal plane over here. The one thing you should remember here is very important thing is the line which is visible in the sense what you have to remember here is the line which is nearer to the observer is taken as visible, and the edge which is away from the observer is invisible. The edge which is nearer to the observer is AB. The edge which is away from the observer is CD. Okay. So therefore, when you are representing it on a top view, look at here. A is the point which is visible, and B is the point which is visible in the top view because this edge is very nearer to the observer. Whereas the point C and point D, they are away from the observer, and hence we consider this as an invisible point, and the edge which connects these 2 points are invisible edges. So when these edges or these points are not visible in any one of the views, either in the front or in the top, whatever it might be, it will be always been represented within the brackets. So you can see the C is in the bracket and D is in the bracket. Why? Because these 2 points are not will be considered as an invisible in the top view. So therefore, we are putting those 2 points as invisible and it will be represented within the parenthesis. So I think you can understand these things. And this is the two-dimensional drawing what we go to do. See, where we are getting this square, the true shape in the front view, and correspondingly we will going to get the top view. Okay, so top view, which we will going to get it, which is A and B are visible in the top view, and C and D are not visible in the. This is just the first position what we are having with respect to the plane perpendicular to HP and parallel to B. Right? And the second position is a plane perpendicular to VP and parallel to HP. A plane perpendicular to VP and parallel to HP. Look at the position, how the plane has been positioned. So satisfying the condition that it should be perpendicular to VP and parallel to HP. This is the position of a plane. Again, we have taken a square as an example over here. So here, the ABCD is a square. So this lamina or this plane is being placed, it has been kept parallel to HP and it has been perpendicular to VP. So as we have the concept, same concept, where the lamina or a plane which is parallel to the corresponding plane, corresponding reference planes, so you will going to get a true shape and a true size. So, and correspondingly, on the opposite side, which is perpendicular, so you will going to get the line, the straight line over here. So we are getting this straight line. Okay. So therefore, this is what we supposed to do over here is the plane perpendicular to VP and parallel to HP here. So this is the position of a plane, so which has been kept, and in the top view you will go to get the true shape of a square, whereas in the front view you can see only the 2 points AB, and the edge which connects AB will be the visible edge, and the 2 points which are away from the observer is C and D, and the edge which connects CD, C and D is a CD which is not visible. The same concept what I discussed for the previous position, same thing will going to be applicable over here also. Okay. So therefore, when you see here, look at here, see the front view, you are getting a straight line, and in the top view, we are getting the plane, that is just true shape and true size of a lamp. So here, the same thing it has been shown in the orthographic view here. See, front view, it is a straight line, and in the top view, we are getting the square ABCD of a given size. Okay, so just observe here again, D dash and C dash. These two are the points which are not visible in the front view, and hence it is been represented in the form of a parenthesis. Clear? These are all some of the things what you can remember. Very simple over here. And this is the one plane perpendicular to both VP and HP. So how you are going to position here? This is a very rare case you are going to get it, because when it is perpendicular to both VP and HP, we will going to get the true shape and true size only in the side view or in the profile view. So I think it is very rare. Only one or two problems are there. And of course, it is perpendicular to both HP and VP. Both front and top views will be a straight line, because the true shape and true size can be seen only in the profile view. Either it is in the left profile or in the right profile. So you will going to get a true shape and true size. Okay, so this is what we have shown over here. Here we are having the straight lines in both the front and top. Hello. If you have any doubts, you can ask me now. Anybody having any doubts? Anybody is having doubts, please ask me. Okay. I will continue over here. So this is the position of a projection of planes. A plane resting on one of its base side on HP, plane resting on one of its base side on VP. So what I am talking about here is, so this is the position of projection of a plane. So where we are having, this is the edge which will be resting on HP. See the plane resting on one of its base sides on HP. So base sides means base side or edge, anything you can take it as. So please remember, in the projection of plane surfaces, when we say the lamina or a plane resting on HP on one of its base edges, the base edge should come to your left. Come to your left. You can observe over here. So you are resting it on horizontal plane. So because horizontal plane will come always below the XY line in the first angle projection. So we are keeping the lamina on the horizontal plane, and then we will going to get, once we are draw, we will go to position the lamina such that the edge should come to your left. Okay, it should come to your left. This is the one important thing what you should always remember. See, look at that. So look at that. All the diagrams what we have shown here, it is a pentagon or a hexagon or a square. So the edges are coming to your left. So this is what we call it as the lamina is resting on HP on one of its base edges. And its true shape. So look at the true shape. This is a XY line. I am drawing, we are shown the true shape of all the laminas on the horizontal plane only. Okay. So this is what the plane resting on one of its base edge on HP. Similarly, a plane resting on one of its base edges on VP. So again, the XY line, VP means directly you are going to write the triangle or a lamina directly the true shape and true size in the vertical plane, such that the edge should come to your left. Edge should come to your left. So therefore, this is a very important thing. That's what I was talking. This is very important from the projection point of view, because initial position, if you make a wrong, then you're going to lose 25 marks. You won't get not even a single marks for making a mistake in the initial position. So please be careful while you are drawing. The initial position plays a vital role. So whether you are resting it on a HP or resting it on a VP, or you're resting it on a edge or resting it on a corner. These are the two important things what you're supposed to remember. So this is the second thing. Plane resting on one of its corners on HP. Look at that. So when the corners on HP, so you are drawing the true shape and true size directly on the horizontal plane, and the corner should come to your left. So this is the one difference what you're supposed to remember. When the edge is resting, you should get edge to the left, and if corner is resting, and corner should come to your left. And second important thing is whether it is resting on HP or resting on V. If it is resting on HP, you can directly draw the true shape and true size in the horizontal plane, where always in the first angle projection you will go to get below the XY line. And when the lamina is resting on VP, so you always get the vertical plane above the XY line, and you will go to draw the true shape and true size directly on the vertical plane. Okay, so please remember this. See, that is the difference between planes resting on edges, planes resting on the corners, because this is the initial position what I am talking about. This will play a vital role. Otherwise, you won't get not even a single marks out of 25. Be careful. Okay. So any clarification, students, you can ask over here. Please unmute yourself, and if any clarification, you can now have your Diveshri. Diveshri, can you hear me? Any doubts?
Yes, sir.
Any doubts you can ask here, because it's very important. Because once we start doing it on a problem, so most important thing what you should remember here is the position of the lamina for HP and BP. Please unmute yourself. Please everybody unmute yourself, and if you have any clarifications, please ask me. Please unmute. Please unmute. Any clarifications, anything if you are having, please ask me. Can you hear me? Ashita, can you hear me? Please unmute. Please, as any clarification is there, we will going to clarify your doubts because understanding the concept, it takes time and you will have a lot of doubt because having a problem. So you're supposed to be understanding this. Please unmute yourself and you can speak. Yasim Hasan, you're there?
Yes, sir.
Yeah,
Yes,
could you
sir.
able to, you could
Yes,
able to
sir.
understand, could you able to understand what we
Yes.
discussed?
Yes, sir.
Okay. So what we do
Yes, sir.
next 1 hour, we will be discussing the problem. Okay, I will go to start with one solving a problem. Please keep all your sketchbook or drawing instruments, everything is ready with you. And if you don't have a sketchbook, please have the plain sheet of paper with you. We will go to start that. This is very important for me because I will going to draw it on a board and I will going to explain how to do. I am going to show one problem and I will going to explain how this problem can be solved. Okay, so please keep it ready. So we're going to start exactly at 9:30. So I have given the meeting ID and everything for that 9:30 class. So please log into that. That is very important for me. Okay. So, Jasim Hasan, could you able to hear?
Yes, sir.
The rest of them can unmute yourself and you can speak to me. If you
Yes,
mute,
sir.
no, only you are there. You are unmuted. The rest of them, they are muted and they are not speaking to me. They could not able to hear or they could not understand. And I don't know. Please unmute yourself and you can speak to me now. Okay, guys, please log into the second meeting at 9:30. So meeting ID and everything I have given to you. Okay, and one thing is you have to have your sketchbooks as well as the drawing instruments with you. So once you start with that, I will going to start with the problems. So please take a break for 10 minutes and you just log into that later. Okay.